Bayes theorem. So Bayes theorem, sum rule and product rule, these are the kind of three pillars in probability. So once you know the sum rule, you know the product rule, and you know about the Bayes theorem, you can solve a lot of questions in this probability. Let us start finding what is Bayes theorem. So here we'll be using the sum rule that you learned and also the product rule that you learned, and along with that we'll derive this Bayes theorem. What it does is it gives a tricky way for you to find probability of y given x. That is, here x and y are random variables. Taken x and y as two different random variables. What is the probability of y occurring given that x has already occurred? That is, you are told that the event x has already occurred. What is the probability of y's occurring? This is Bayes theorem. So let us have a revisit of product rule. In product rule, we learned that P of xy, this can be expressed as P of y given x into P of x, right? This is what we learned in product rule. From here, if you want to find this P of y given x, what can you do? You take this x and put as the denominator here. You take this P of x into LHS, left hand side. So then what will P of y given x become? It will be P of x and y, that is probability of x and y occurring together, divided by the probability of x, right? So from using the product rule, we made this particular statement. So now we know probability of y given x is probability of x and y occurring together divided by the probability of x occurring alone. That is, occurring alone in the sense irrespective of the value of y, what is the probability of x? So what is the other way of reframing the same statement? This can also be written as probability of yx divided by probability of x. Do you agree with this? Because what is probability of xy? Probability of x and y occurring together, right? What is probability of yx? Probability of y and x occurring together. X and y occurring together and y and x occurring together are one and the same. So you can write probability of xy as probability of yx, right? Now let us take the product rule again. Product rule. What did you learn from the product rule? How to find the value of P of xy. So instead of xy, let us this time write it as yx. What will be P of yx according to the product rule? It will be probability of x given y into P of y, right? From the product rule, we have this formulation. If we substitute this value here, instead of P of yx, we are going to substitute this value, P of x given y into P of y. So once we substitute that here, we will get, instead of this, you will get P of x given y into P of y, right? You agree with this? So now we have probability of y given x is equal to probability of x given y into probability of y divided by P of x. The next step is we are going to recall our sum rule. What is the sum rule of probability? From sum rule, you have probability of x is equal to summation over all values of y, P of x, y, right? This is the sum rule that we learned. And this value of P of x, we are going to substitute here. So what will we end up getting? If we substitute the value of P of x here, I'll write numerator as it is, P of x given y into P of y divided by summation over all y, P of x, y. So we use the product rule and the sum rule to reach this particular finalization. So Bayes theorem says probability of y given x is probability of x given y into probability of y divided by summation over all values of y, P of x, y. So this is the Bayes theorem, but here I can do a bit more of work using the sum rule. So what can I do here? Other than this, I already applied the sum rule. Instead of this term, can I do something else? Just think, what if I apply the product rule here again? See, what does the product rule says? I'll rewrite this neatly here and then let us continue. P of y given x is equal to, I'm just copying what the result that we got, probability of x given y into P of y divided by sum over, okay, sum over all y, probability of x and y occurring together, right? Now what I'll do, I'll take the product rule again. So this whole derivation is made up of product rule and sum rule. We'll visit product rule again, sum rule again, and come to the derivation. From the product rule, we know P of xy is equal to P of y given x into P of x. We also said P of xy and P of yx are one and the same, right? So instead of P of xy, I can use P of yx, right? So instead of pxy here, I can write P of yx. So instead of xy, what if I write it as P of yx? If I write it as P of yx, this will become P of x given y into P of y, right? So this term, instead of this, I can substitute this thing. So what will it become? This whole thing will become probability of x given y into probability of y divided by summation over all values of y, P of x given y into P of y. So these are the two important forms of Bayes theorem, that is this first derivation and then this second derivation. This is what you call as Bayes theorem. So in short, Bayes theorem is used to find an estimation of what is the probability of an event y if you are given that the event x has already occurred. In that case, we have derived Bayes theorem, which is probability of x given y into P of y divided by summation of all the terms of y, P of xy. Another form of writing the same thing is this. So depending on the situation, you may have to use either this form or this form. So here we found that the same thing, probability of y given x, can be expressed as probability of x given y into P of y divided by summation of all terms of y, P of x given y into P of y. So this is what you call as Bayes theorem.